So hello everybody, and I hope everybody in my mba502 class is well. I'm going to go over. I want to go over some stuff in chapter 5 here. I got chapter 5 up about interest rates because there were some questions about interest rates, and of course I'll finish this Thursday because we didn't get a chance to go through it yet. But some of the notation that's used in the chapter is you notice the word EAR, that's effective annual rate. Again, that's the rate that basically is used with regard to compounding. The more you compound, the higher that will be. Okay, here's the interest rate, or this is also called the discount rate, and sometimes and here's the present value, and here's the future value, and we'll go over these. And C is a cash flow. The APR is where you determine the EAR from. So the APR is the annual percentage rate, and K is the number of compounding periods per year. And the real rate of interest is the interest in the economy, sometimes known as R star. Okay, before you add inflation and premiums to increase it to a higher level. This is the lowest rate you'll ever have, but it's never really a true rate because there's a lot of terms added to it. Liquidity and maturity. All right, here's the rate of inflation, which everyone should be concerned about, right? Because this lowers your buying power. That's I. NPV is net present value. And these are your periodic cash flows. And basically, when you see RN, that's the interest or discount rate for N-year term. Okay, and this is the tax rate. Tau. It's not T, it's tau. All right, so the equation, the first thing is the things are stated as normally as an effective annual rate. Okay, so as we see here, if I have an interest rate R that's paid at the end of 1 year, after 2 years, you'll notice it's squared here. So you'll notice that the interest you're going to accumulate now is more than an extra $5,000. Normally it would be $110,000, but because of the interest on interest, you'll get an extra $250. Okay, so here's that $110,250, and of course that correlates and corresponds to an interest rate of 10.25%. If I took this number here and divided it by 100,000, I would end up with 10.25%. All right, so we can, and again, you could do the same thing going smaller. So you notice what they say. We can use the same method to find the equivalent interest rate for periods shorter than 1 year, right? So when I say shorter, right, it's like, let's say 6 months. We raise the interest factor to the appropriate fractional power. So earning 5% interest in 1 year is equivalent to receiving $1 and 2 and change cents, right? So if I had this is over here, there's an imaginary $1, right? So in 6 months, I would have $1 and 2 and a little bit more change, right? So you notice what it says: for every dollar invested every half year, or equivalently every 6 months, that is a 5% effective annual rate is equivalent to an interest rate of approximately 2.47% earned every 6 months. And if you take 2.47, and you could see here, if you compound that every 6 months, right, 2.47, you'll get that 5%. So in general, right, and this is a nice equation to know. This is one of the most important equations. In general, we can convert a discount rate of R for 1 period to an equivalent discount rate for N periods using the following formula. So this is the equivalent N period discount rate, and 1 plus R to the N minus 1 okay, will give us, like, I guess, a 5-year rate. So it all depends on if we want to go further out for 5 years or 2 years or less than a year. So you can see over here it was greater than 1, and over here it was less than 1. So they make an interesting point here. In this formula, n can be larger than 1 to compute a rate of more than 1 period, or smaller than 1 to compute a rate over a fraction of a period. When computing present or future values, it is convenient to adjust the discount rate to match the time period of the cash flows. And I give some examples here, and you can clearly see, here's the cash flows, right? So suppose your bank account pays interest monthly with the interest rate quoted as an effective annual rate. Now you notice here they clearly spell it out. They 6% is the effective rate. What amount of interest will you earn each month? If you have no money in the bank today, how much will you need to save at the end of each month to accumulate $100,000 in 10 years? So from equation 5.1, which basically we saw up there, a 6% EAR is equivalent to earning basically 0.4868% per month. And you'll notice it's 1/12 here. They take this the effective annual rate of 6, and they come up with a monthly rate. So basically, if you take this and bring this to the 12th power, you will see that you will have a effective rate of 6%. So the cash flows are going to be over 10 years, right? They said 10 years. 10 years, and it's monthly, so it's 120 pay periods. 10 times 12, right? So you want to accumulate, which we'll go over it in further detail. I'm doing a little time value of money here, which I should have done already. But so the future value of this annuity, which we'll talk much more about, is going to be C times 1 over R, right, to the 1 plus R, and don't worry about this equation, we'll go over it, to the n power. So what they're going to try to do is they're going to solve for C here, because you know that F of V is $100,000, right? They already told you want to have $100,000 over here after 10 years. So we can solve for the monthly payment using this equation, and again, we'll go over this equation. So the bottom line is this. You've got to put away $615.47 per month. So after 10 years, you will accumulate $100,000, which is right here. Okay? So if you use the Excel, here you notice there's 120 pay periods. Here's the rate, the effective annual rate, which we calculated right there, right? And if it was an APR, this would just be an APR, but here they clearly say it's an effective annual rate. And here's the present value, which is 0, and you're just making basically, so here's what you're calculating. You want to get the payment. This is what you're looking for to get $100,000 after 10 years. So you would have to put away, notice it's negative, because you'd have to put this in the bank after 10, after 10, every month for 10 years. Comes out of your pocket. Negative money comes out of your pocket, okay? Thus, if we save $615.47 per month, and we earn interest monthly at an effective annual rate of 6%, and you notice again, they use the word effective annual rate, we will have $100,000 in 10 years. Because you're going to be, and it's effective rate because you're going to be getting interest on the interest, right? So that's how that's done. All right, so I'm gonna make these in 10-minute chunks, and I will send you more later. I don't want to make these too long because they get too big, and then you got to stay up quite late to look at them. So I'll stop here, and I'll pick up over here and make the next video.